I'm going to explain about Chebyshev inequality. Chebyshev inequality will gives the maximum upper bound from its mean. One is upper bound, or else it is also named as maximum dispersion from its mean. Maximum dispersion will gives the from its upper bound. Dispersion. So means upper bound from its mean means that is random variable x from its mean. So this is the maximum limit. So it is not an unlimited. So deviation, it should be some constant. Then only we can calculate the expected value e of x means mean or else average. I will tell you I will explain the formulas anyhow. E of x or else mean square sigma x square second average, that is e of x square. E of x square. So both the values are calculated by using Chebyshev inequality. So means it will decide, the Chebyshev inequality will decide the maximum limit from its mean. This is x minus m value will decide. So that is the upper bound from its mean, or else that is maximum upper bound of this dispersion. So or else maximum limit, you can easily say that this is the maximum limit. So that is about Chebyshev inequality. So Chebyshev inequality will gives the maximum limit from its mean or else maximum dispersion from its mean. What is the use? So by using this we can calculate the first average as well as the second average. So we know that already. This is the Chebyshev have given this. So that is I will prove this anyhow. That is x minus m or mu or m, both are same. We can indicate it with the small m, mean, or else mu are the mean values. Sigma is the standard deviation, 1 by k, that is standard deviations. K means standard deviation, number of standard deviations. So I will give the explanation. Before that, what is the mean? You should know that. Mean, you know that. Mean or average is equal to E of x. Mean or average in random variables. Generally, 2, 3, 4 mean is 2, 3, 4 by 3 is equal. 3 is an average. 9 by 3 means 3. So in random variables, we can calculate the mean like this. We know that for continuous random variable, minus infinite to plus infinite f of x dx. This is the mean, first mean. We can call it as first mean. If it is not satisfied in random variable, then we are going for second mean. So that is called as e of mean square value. E of x square is equal minus infinite to plus infinite x minus m whole square into, that is second mean, sigma x square, denoted with sigma x square, or else it is also named as variance. Variance already we have discussed, into f of x dx. F of x dx. So this is the first mean, first average. This is the second average. So by using Chebyshev inequality limit, we can calculate. So this is not unlimited. What is saying Chebyshev? This is not unlimited. So it is having some bound. Upper limit is there. So that is the Chebyshev inequality. The deviation from random variable x is some deviation is there. So that will gives the Chebyshev inequality. So we will go for the proof. We know that the second mean variance. We know that variance sigma x square is equal minus infinite to plus infinite x minus m whole square f of x dx. F of x dx. Expand this is assuming some limits, that is average limits he is assuming. So the limits are from minus infinite to m minus k. He is assuming x minus m whole square f of x dx plus again m minus k to m plus k x minus m whole square f of x dx. Next limit. Next limits are is assuming m plus k to, these are the limits, m plus k to infinite x minus m whole square f of x dx. f of x dx. Now he is assuming that is one is plus, one is minus, so it will cancel, that is equal 0. Assume that. So then the remaining terms are this minus infinite m minus k x minus m whole square f of x dx plus m plus k to infinite x minus m whole square into f of x dx. But two terms only now it is, but previously it is three terms. So that's why two terms average, two terms value is definitely sigma x square is greater than, compared to three terms it is greater than, or else we can write it in one more step. We can minus infinite to m minus k x minus m whole square f of x dx plus remaining term is m plus k to infinite x minus m whole square f of x dx. So therefore only two terms only, so definitely it should be greater, because it originally it is having three terms, but now it is only two terms, so that's why sigma x square is greater. So therefore now he is assuming that is x minus m, let the standard deviations, that is dispersions, is x minus m is equal k. So then we can write it as sigma x square greater than or equal minus infinite to m minus k square f of x dx plus m plus k to m infinite k square f of x dx. So k square common and take it this side, sigma x square by k square greater than or equal, remaining terms are minus infinite to plus m minus k f of x dx plus m plus k to infinite k square already gone, that is f of x dx. Now we can see this, what is this is the upper limit and this is the lower limit. So take the limits only, sigma x square by k square greater than or equal probability of x minus m minus k is the lower limit, means lower limit m minus k is a lower compared to limits x, so means less than. Here m plus k, sorry, m minus k is a higher limit, upper limit, sorry, m minus k is a upper limit, that's why it is greater. And here m plus k is a lower limit, you can see this m plus k, here you can see this m plus k is a lower limit, so therefore it is a lower, so that is the reason m plus k is less than or equal to x, less than or equal to x. So now take it this side, m value take it this side, so we can write it as probability of p of minus k greater than or equal x minus m greater than or equal, you can write it. Next, take this m from this side, it is also x minus m, take this side x minus m greater than or equal to k, greater than or equal k. You can see this x minus m value is 1's minus 1's plus, so that's why you can write it as modulus probability of mod of x minus m mod of greater than or equal to k, greater than or equal sigma x square by k square. So this is the Chebyshev inequality he has given. So this is the limit, this is the range for Chebyshev inequality. So that is about Chebyshev inequality. Chebyshev inequality will use it to calculate the first mean and second mean. But in second mean, it will gives the maximum upper bound from its mean, maximum dispersion from its mean. So using variance, we can prove that. Thank you.